Okay. So today we will start with a new topic on irrigation efficiencies. So far we have looked into the various aspects of how to compute the evapotranspiration requirements of the crops. And the next aspect which we want to dwell into is the various methods by which we will distribute the water to the crop surface or the fields. And before we do that, because there are various techniques, there are various ways by which you can supply the water, irrigation water to the irrigation field, the crop fields. Before we go to that level, we want to find out what are the ways and means by which you can look into which is the best way of applying the water. So there the question of efficiencies come in. How you define efficiency in general? When you look at the efficiency in general, what is it? Is the ratio of an output to input. That is what you mean by efficiency in general. And you can also say that this is the quantity beneficially used to total quantity which you have received from the supply. So this is more closer to the irrigation aspects. What you are doing is that you are supplying, you are diverting some water from the source. The source can be either in the form of a reservoir, or the source can be groundwater tube well, or a source can be tank. So the sources, there are various forms of sources which you can make use of in terms of the artificial irrigation. When I say artificial irrigation, because there can be a possibility of having the irrigation water available because of the natural inputs, because of the natural rainfall. So then in that case, if the sufficient quantity of water is available from the natural sources, then you might not need the water to be diverted onto the fields with the artificial means. So when we say that the water has been diverted from the reservoir, again the water in the reservoir is again the irrigation, the rainfall water, but that has been stopped at a particular level, it has been stored, and then you are making that water travel from that source to the fields wherever is required and whenever is required. So that is the difference between the water which you are getting from the rainfall and you are making it stored at the same place or in situ in the fields. That is the water which is the effective rainfall. What we are terming it as effective rainfall. That is the rainfall which becomes effective at that location in the field. So the other water which you are diverting from some source and taking to another area of interest, that is the irrigation water, that is the artificial irrigation which we are discussing now. So when you say the quantity beneficially used, first of all the quantity of water, we normally are dealing with the volumes of irrigation water. When we are talking of quantity, we mean the volume, how much volume of water has been diverted or it has been applied onto a field, and the beneficial usage of this quantity. The beneficial use can be in the form of, now we know that there are various forms of this beneficial use. The primary is because of the evapotranspiration requirement, which is made up of the components. One is transpiration, and the other is evaporation. The evaporation can be from the soil or from plants. So that is what is the evapotranspiration component. We have gone into details of this component. The other beneficial uses can also be incorporated when you are looking at the quantity which can be used beneficially. The other usages can be, maybe there can be some quantity which is used for leaching. Leaching of the soluble salts. So when you want to displace those salts, or you want to flush those salts which are not very useful salts for the crop production, or their concentration is, sometimes the salts can be useful, but once their concentration goes high, they can no more be useful. So they can affect the growth of the crops. In that situation, you would like to flush those salts below up to a level which is beyond the root zone depth. So that process is known as the leaching process. So any water which is used for the leaching purpose can also be called, it can be termed as the beneficial usage of water.
So how evaporation can be considered as a beneficial use? It's actually lost from the soil.
Yes, the question is that how the evapotranspiration can be. The evaporation can be termed as the beneficial use. Here, that is where the method, which method you are using, will come into picture. Because if the method is such that you cannot avoid that evaporation from the soil, then that is an inherent component of the beneficial use, because you cannot avoid that. For example, if your method is such that you have to wet the whole surface, you are using the gravity flow. In that case, unless you let the water move from one end or the upstream end to the downstream end with the help of the slope of the field, or even in some case you are using the surge of the water, in that situation is not possible not to wet the total area. In some cases, yes, if you have shaped your field in a way and that you can avoid wetting the whole area, even in the case of the surface flow, which will cover, which is the furrows case, still majority of the area will be wetted, and that wetting is not, it cannot be avoided. So that is the reason that it has to be taken as something which is not avoidable. So anything which is avoidable and you are still making you are incorporating that, then is not a beneficial use. But in this particular case, if the soil evaporation cannot be avoided, then it has to be part of the essential usage. If not beneficial, you can say is the essential usage. So leaching, and similarly there can be some other requirements. In some cases you want to keep the temperature of the crop down, and if possible, I mean if you are using the sprinkler irrigation method, then you might use that component which you are using for lowering the temperature, that can also be termed as one of the essential requirement. So, for the temperature control, similarly for the frost protection, if the area is having the frost problem, then again you might be using some water to avoid the frost, because frost can be detrimental again for the crop production. So, in that situation, all these things are part of the beneficial usage. So, in literature, you will find that there are many different efficiencies which have been defined with the intention of giving the user some possible yardstick or some possible indices where they can compare their efficiencies with, in terms of knowing how effectively they are using their systems, how effectively they are managing their system. So, basically you are using the efficiencies for comparison of different systems. If you want to check whether one method is better than the other method in terms of some efficiencies, you can use those efficiencies for the comparison of the effectiveness of various systems. Yes, please.
So how you can compare the two efficiencies if drip irrigation method doesn't involve the evaporation loss, and how we can compare?
Yes, in that case, we'll come down to, let me just, he wants to know whether, because he has some idea about which are the various methods which we have not yet discussed, because at this stage I am trying to talk in terms of the general efficiencies. The actual usage of these efficiencies will be more clear when we'll go to the various methods, and we have covered those methods, what those methods involve. But at this stage, if you want to know that in the case of drip irrigation system, you have a situation where you are not wetting the total area, you are only that portion which is supplying the moisture to the root system is getting wet. So, in that case, that particular efficiency which is talking in terms of the water usage at the plant level, that will be highly influenced. But the other efficiencies might not be influenced when you talk in terms of the conveyance, all those things. So, we will come to all those individual things, because the efficiencies, one I have said that is it will give you a yardstick in terms of comparison between the various systems, and it will also give you the strategies. Different strategies for management of the system. If you want to, some of these efficiencies will be geared towards these aspects, that if you want to manage your system in different ways and you want to know what is the impact of that change in the management strategies, how you are going to evaluate those aspects. So, these two are the basic reasons that why the different efficiencies which we are going to cover now, they are defined, and there are many of them. You will find that there is a lot of overlap also in literature. There will be many different ways people have defined these efficiencies, but we are trying to cover some generic efficiencies which can be applicable to all the methods, irrespective of which method you are talking about. They will be more or less, most of the time they will be having a clear picture, a clear understanding, a clear meaning of those efficiencies. Otherwise, in literature there are situations where people have defined the efficiencies which are only applicable to those individual systems. So let's look at what are those individual efficiencies. In general, they can be categorized in different groups. Group A will put those efficiencies which are based on measured volumes. Then group B will discuss the efficiencies which are based on measured depth of application. And group C will discuss some other efficiencies which are based on some other criteria, and most of the time this criteria is dependent on or is related to the yield of the crop. As any efficiency you look at, the end interest or the end users, the farmer's interest is in the yield of the crop. So that is the ultimate thing. So even if you are talking in terms of the water utilization, or you have already seen that the water utilization is directly related to the yield of the crop. If the water utilization is reasonable, is optimal, then the yield of the crop will also be optimal. So from that angle, there are some efficiencies which are defined with respect to that criteria, that looking at the yield of the crop, how you can evaluate your utilization of water. Under group A, the various efficiencies which are quite commonly used. First one is extraction efficiency. What is extraction efficiency? It is defined as the ratio of the volume delivered to the distribution system to the volume extracted from the source or the supply. In this case, what is reflecting is that how efficiently you are extracting the water which you are going to use, or in a way is also giving you some idea. Suppose there is a reservoir. Now from the reservoir you are releasing some water to be tapped at some lower level where you have the distribution system, or at a level which is in the canal. From the reservoir you are having a river or the canal, and from the canal the water is getting diverted to the distribution system. So the extraction efficiency will be the water which you have delivered to the distribution system and the water which was released from the reservoir. So if there is a loss in between, then you are having their extraction efficiency in that case can be reduced. Yes.
Is it the same as conveyance efficiency?
Conveyance in that segment, yes, is part of them. In some cases, people are combining the two efficiencies, the conveyance within the system and the conveyance above the distribution system. So if you separate them out, there can be some conveyance loss above the distribution system, there can be some conveyance loss within the distribution system. So this is the conveyance loss above the distribution system, and that is why it's called extraction efficiency. Is a term which is now being used more often, just to differentiate the two. That is the problem, because these things, all these efficiencies, they are also to be used to for the purpose of diagnostic analysis. If you want to diagnose the inefficiencies in your system, you don't know how to start with that. You don't know. If you look at only the overall yield, you know that the yields are low. You know that that is because of the fact that if everything else is all right, if you're done, if your manure is fine, if your soil is fertile, everything else is okay, there is some problem with the water utilization. So where is the problem? You want to isolate those actual situations, or isolate those segments of the irrigation system where the problems are. So that is what is the diagnostic analysis, and for isolating those segments, these efficiencies will help you, because you are trying to, through these efficiencies, you are trying to synthesize the whole system. You are trying to look at the various segments of the system, and wherever you find that the efficiency, relevant efficiency is very low, you can try to plug those loopholes. So the next one is, as she has pointed out, that this is part of the conveyance efficiency, the extraction efficiency. The next one is the conveyance efficiency. Let's call it AC. This is also something similar to the previous extraction efficiency, but for a different segment. This is defined as the volume delivered to the application device devices by the volume delivered to the distribution system. And 200, because you express these efficiencies in terms of percentage. All these efficiencies are expressed in terms of percentage. So in this case now, the volume which is delivered to the application devices. Now application devices is a general term used intentionally here. These application devices can be in some case, in the case of the systems which are using the gravity flow, it can be sort of the ditch itself, or it can be in some case the perforations available in the channel which are giving the input to the furrows, or it can be some other device. But if you look at the sprinkler system, the device can be the nozzle itself, the nozzles of the sprinkler system. So this term give you the indication that is the volume which is going to be delivered through these devices onto the fields. So any loss which is taking place in between that level and the distribution level, the water, the place where the water has been received for distribution, that is going to give you the conveyance loss. Okay. Then we have application efficiency. The application efficiency is defined as the volume delivered to application surface by the volume to the application device. It may happen that you have brought the water to the level of the application device, whatever device you are using. Now between that device and that device is going to deliver the water onto the surface of the field. Now between this process there can be some losses, and the losses can vary from method to method. If you assume that you are using a sprinkler irrigation system, the moment you are leaving the water is leaving the sprinkler head, you will find that there can be some loss, a considerable loss, if the wind is blowing at a very high speed, because most of the water which is coming out of the nozzle, it might get drifted before it reaches the surface on which is intended to come. So in that case the application efficiency can be very low, whereas the chances of the water getting applied onto the surface using the conventional surface irrigation methods, where you are using the gravity flow, the level of application efficiency can be comparatively higher. Okay. So this will give you an idea that between that level of the application device and the level of application surface or the field, what is the amount of loss which is taking place. Then there is another efficiency which is called distribution pattern efficiency. I'll call it EDP, and is defined as volume stored in the root zone during the irrigation to the water delivered to the application surface. Again, in normal practices you will find that these two application efficiencies, the one which we have mentioned earlier, the application efficiency and the distribution pattern efficiency, they are clubbed together. Invariably you will talk in terms of how much is the volume which has been delivered to the application surface and how much is the volume of water which is stored in the root zone. So these two are taken as the application efficiency in general. But if you want to divide the two and look at how much is the impact of the things like the distribution pattern, which will be quite apparent in the case of the sprinkler systems, where the losses can be quite high, you will find that this differentiation between the two parts, as we have seen in the case of the previous case where the conveyance efficiency was divided into two components. Similarly, in this case also, you are dividing the application efficiency into two parts. One is what is the difference between what has been supplied and what has been received, and then subsequently out of the received how much has been stored into the soil. Because out of the received quantity there can be some loss, maybe because of surface runoff, it can be a loss because of deep percolation. So all those things can be taken care of if you take these two in combination. Okay. But in general, if you club the two, still you will be getting only the application efficiency, the overall application efficiency, and that will be the ratio of the volume delivered to the or the volume stored in the root zone, because this and this will be this cancelled, and it will be the ratio between the volume stored in the root zone to the volume delivered to the application device. Is that clear? And that is the reason precisely that why there are so many of efficiencies, because is dependent on the conceptions used by the users or the designers, which are the aspects which they want to look into, how minute they want to go into these aspects, and accordingly they have to define those quantities and come out with some indicators which can be used. Then we have water storage efficiency. Water storage efficiency is the ratio between volume stored in the root zone during irrigation to the volume of water needed prior to irrigation. This efficiency is defined to find out how effectively you have been able to remove the deficit which was there in the root zone. The volume of water needed prior to irrigation, how you will find out that? It will be basically the field capacity minus the moisture content at that time. At the time when you are, so this component, the volume of water needed prior to irrigation, you want to bring the water to the soil moisture to the field capacity level. So the deficit is the difference between that level and the moisture content at that instant. Now out of this deficit, how much of the deficit has been removed? That is what is shown by the water storage efficiency. Now it can also be said that there is something which is dependent on the management. How you might not be willing to bring the level to the field capacity level all the time. You might be intentionally reducing the moisture up to a particular level, or the moisture deficit up to a particular level, and you are not intentionally going to bring the moisture content to the field capacity level. So in that situation, the water storage efficiency is not reflecting what you want to get. So this storage water storage efficiency is subject to the situation where you are trying to bring it to the field capacity level, but is not coming to the field capacity level because of some other reasons, or you want to find out how effectively the storage has been made in the process of irrigation in the root zone, with the assumption that you want to bring it to the field capacity level. You also sometimes want to know the irrigation system efficiency. Now, irrigation system efficiency is basically the overall efficiency. You have seen all the individual efficiencies which the system can be divided into when you have intentionally divided the total system into different components, and you have tried to look at various components and assign those efficiencies or define those efficiencies in those segments. But if you want to look at how the overall system is performing, then you can define this irrigation system efficiency, which is nothing but it gives you is the volume of water stored in the root zone, which is your ultimate aim, to the volume extracted from the supply or the source. So this ratio, in other words, is nothing but is if you combine all the efficiencies, the extraction efficiency, conveyance efficiency, application efficiency, and the distribution pattern efficiency. And since these are in percentages, you can bring into the fractions and multiply it by 100. That is what will be your irrigation system efficiency. But irrigation system efficiency, again, many times you can switch or you can change your point of interest. If your point of interest is the source itself, then it will be the project efficiency. In that case, it will be termed as that means if I am considering this volume extracted from the source, then sometimes it is called either the irrigation system efficiency or the project efficiency. If I bring down this level of interest, if I am only interested that what happens after the farm, there is a farm head gate. So, in that case it will be called farm irrigation efficiency. That means I take, in the case of farm efficiency, it will be the volume of water stored in the root zone to the volume of water delivered to the farm head gate. So, what is my input level? If I shift my input level, accordingly, in that case what I am considering is, I am considering the conveyance beyond that farm or within the farm. What is the conveyance losses? I am considering the application losses within the farm, all the other losses, but my point of interest is brought down to the farm level. So, it will be called the same thing, the irrigation system efficiency will be called in that case the farm irrigation efficiency. If I bring it to the field level, then it will be termed as the field irrigation efficiency. So, is a question of which level I am talking about. Accordingly, the irrigation system efficiency can be defined, and it will include all those. It will be a overall efficiency from that point onward, or with respect to that point of your interest. Okay. Now, so far we have seen all those efficiencies which are concerned with the volumes of water only. That you are checking how much volume has been delivered and how much has been consumed inside the field ultimately, but you have not looked at how this volume is being distributed. It can be, I can give you a situation that you have your end product was, your end result or the interest was that you have this field where you are using a surface irrigation method for distribution of water. There is the upstream level of the field, there is the downstream level, and you knew that this was the requirement, this much depth of water was needed throughout the field. So, this is the deficit which is created. You want to satisfy this deficit. Now, in order to satisfy this deficit, you know the total volume requirement. But if you say that you have provided that volume at this upstream level, how this volume of water has been distributed into this total length of the field, unless it gets distributed in a way that you have minimum variation, unless that happens, is not of much use. Because if I try to divide the water in such a way that I have this much water here, this much water here, the volume is same. The volume is same, only problem is that in this part of the field, the amount of moisture which is available is much less than this much part of the field has got all the required quantity of water, and this was the requirement, and it has received all the required quantity up to this level. But in this particular case, the required was this much, but it has received only this much. So, there is a deficit which is still prevailing, and this deficit has not been taken care of. Though you have supplied the total volume which was desirable, which you have which you wanted to deliver to this field. So, if you look at the efficiency which is defining that segment, which is the application efficiency, it will give you application efficiency which is very close to 100%, which is very good, because you are looking only at the volume, but in fact you are not doing the right thing, because the deficit has not been taken care of uniformly throughout the field. So, to look at those aspects, you have to define some more indices which can throw some light on those aspects of distribution of water. And to do that, that is what we had said, that group B efficiencies will look at the distribution aspects or the depths of water, and the efficiency which is used to do that is known as water distribution efficiency. Let us call it ED, is defined as 1 minus y bar by d bar where d bar is the average depth of water, stored during irrigation, and y bar is the average numerical deviation and depth of water stored from average depth stored during irrigation, which is nothing but d bar. Let us look at this in terms of, let us say that, suppose the depth application, this is the way the depth has been applied, because in normal situation, whenever you use the gravity irrigation methods, you will find that the upstream will be getting comparatively higher amount of moisture than the downstream areas. So, suppose this is the depth from upstream end to the downstream end. This is the depth which you have applied. What is the average depth? This will be the average depth of application. So, this is nothing but this is a d bar. And the y bar will be depending on how many, suppose if you take many sections, the more the number of sections you take, it will accordingly, the value will remain same, but the accuracy will increase. So, if you take the sections at this interval, you will find that the deviation of the actual depth from the average depth will be these are the deviations, and if you take the average of these deviations, if this will be closer to the, for example, if we draw another situation, now if the actual application is this, in this case this is the average depth d bar, and the deviations are now much smaller. So in a situation where the deviations are more, you will get a value. You will get a value for this part. You have a value which will be very small value, and the distribution efficiency will be very high if the deviations are very small. If the larger the deviations, the larger will be the component on this side, or this y bar by d bar. It will be more than it will be, its order of magnitude will be larger, and the word distribution efficiency will be lower. So that is how you can see that the word distribution efficiency will give you an index of the uniformity of the depth which you have applied onto the field. Okay? Any question? We are left with less time. We won't be able to finish this, the group C. So we'll stop here, and we'll take up this the next class. Thank you.